want, you have to then set up a trap for a victim. And you get the victim to run into your trap, and then you get your goal that you're trying to achieve. So that's where the attack vector in terms of the likelihood of successful exploit was the third factor. So with those three factors, we multiply those together. That gives us a likelihood score. Multiplied by impact, that gives us an impact score. And finally, we get a score. Now, you'll notice if anyone's ever actually looked in the details, I have one exception to our high, medium, low kind of scoring. Because cross-site scripting is so prevalent, I gave it like an extremely high prevalence score, which, of course, changed the mathematical model slightly and kept XSS in the spot that I wanted it to be. So if you think I was cheating and XSS belongs at number 3 instead of number 2, that's fine. But that was my one tweak to the standard low, medium, high kind of model. But in my experience, like we'll find, let's say we find 30 flaws in an application, we'll find 16 cross-site scripting flaws, and the other 40% might be the rest, as an example. It is just incredibly prevalent in certain applications, of course. So that's our risk rating model. Now, the other thing we didn't do was we don't know the threat agent in your environment. We don't know how likely it is a bad guy can get to your environment and try to launch one of these attacks or discover this flaw. And we don't know the business impact of this thing to you. We know the technical impact. I know with cross-site scripting what I can technically do with it. I know with SQL injection what I can technically do with it. But I don't know the business impact to you in your application. So we couldn't include those. Now, those in any risk rating model in the real world where you are doing this in your environment, you would absolutely have to take those into account. And then the thing you wouldn't have to take into account is the prevalence issue. It's either there or it's not. I know it's there, 100% prevalence. I know it's not there, or at least I couldn't find it. It's not there at all. So when you take this top 10 and use it in your environment, you have to consider a few more factors, and you have to calculate your own ratings. So the top 10 is just a guide, but you need to tweak this and organize it for what makes the most sense for you. So for some of our clients, cross-site or SQL injection, which is the number 1 on the list in terms of risk, isn't even on the top 10 list of some of our clients. And the reason for that is they've been dealing with it very successfully for half a dozen or more years. It's just gone because it's not that complicated to get rid of it. So there's been some talks earlier this week about how to get rid of SQL injection and things like that, and people say it's so easy, and it is, and yet we obviously aren't succeeding because it's still number 1 on the list. So we're not doing something right. I think we maybe need to change the technology or change the language or come up with some new paradigms for how to do it. But actually, in terms of education, it's actually not that hard to get rid of. So I'm not quite sure if we need to change our paradigm or if it's just a lack of awareness. So this is the new top 10, and the ones in red are, of course, the new ones. And, of course, the 2 other ones dropped off the list. So let me go through each one of these in the time that I have left. I have about, I guess, 20 minutes or so. So injection. The first category is not just SQL injection. It's about all kinds of injection. Applications use interpreters to process commands in various contexts. The most common one is the database. But there's many other kinds of interpreters that we use. The underlying operating system, if we're calling it in like a shell, for example. Our LDAP directory. Our XML files that we're doing queries against. In fact, as technology moves to more and more of a text-based approach, more and more of our environments involve interpreters. So the web went to HTML and JavaScript many, many years ago. Now we're moving to XML. So more and more often, our data is text. And we're rendering that data in environments that use text as data and as commands. And it's easy to get the two of those mixed up, particularly if you're trying to do it on purpose, like an attacker does. So we need to figure out a way to make it easy for developers to make it clear this is data and not code, and don't ever treat it as code. So I wish we could just build user interface frameworks, for example, that would know what is text from the user and what is JavaScript that the developer wrote, and we can eliminate cross-site scripting easily. I wish we could just have database interfaces where we can ban the unsafe interface and only allow the safe interface. Unfortunately, right now we've got both interfaces available, and the developers use the wrong one. It's that simple. It's not that complicated, but people aren't doing it. So we're obviously failing somewhere. So how does injection work? Well, you guys are all pretty familiar with that. The attacker provides some script into some input. That input gets combined into a big string. That string gets passed into the back end or some interpreter, wherever that is. And we know the red bad attack came from the user and the black code came from the developer, and that they should be separated. But by the time it gets to the interpreter, it doesn't have the clues it needs to know the difference. And so, unfortunately, the attacker's code gets executed rather than treated as data. So in this example, all the data comes flying back out to the application, right? So SQL injection, incredibly simple problem, incredibly easy to avoid, and yet we're still finding it a lot. Now, in terms of prevalence, it might be fading slightly, maybe. I didn't do a statistical comparison between 07 and 010 to see, is it actually going down? But the impact is so huge if you have a SQL injection flaw that that's why it showed up as #1 on the top 10 list. It's not the most prevalent flaw, but it introduces the most risk if you have this problem. So how do you fix this? Well, for all types of interpreters, first off, if you can avoid the interpreter entirely, that's a great mechanism, because then there's nothing to confuse code and data. Now, not all environments offer the ability to avoid the interpreter. Databases have two modes. Use the interpreter or use code that you've either built into your app or already built in the database. And yet we're using the wrong one many times. Some of the newer technologies, like I've looked at like LDAP queries and XML, XPath queries and things like that in a particular technology, in a particular environment, and I'm like, okay, I'm using an interpreter. All right, where's the safe version that's not using the interpreter? And it doesn't exist. And that's unfortunate. So we need to get non-interpreted interfaces available in all of these environments to make it easier for the developers to do it safely. So if we don't have that, then what do? Well, we encode or we validate. Now the difficulty with, first off, whitelist validation is super important. You should all do that on every parameter, every time, but that's hard sometimes. Like how do you validate a blog entry or the comment to the webmaster or whatever? So you do the best input validation that you can, and then you assume that it failed, which is a nice, safe assumption, and then you make it safe anyway. And the way you do that is encode. You encode the data with the encoder that's appropriate for the interpreter you're using. So if you're going into an Oracle database, you use Oracle encoding, whatever that is. If you're going to an LDAP injection, you go to an LDAP, you use an LDAP validation, or encoding, sorry. Etc. So the thing we need to do is we need to get developers to recognize that there are encoding mechanisms. It's a standard defense. We need to make it available to developers and make it easy for them to recognize when they need to use them. So one of the things that's also new in the last year or 3 years is OWASP is starting to write a series of cheat sheets. And if you're not familiar with the cheat sheets, I would certainly encourage you to get familiar with them. They're probably the most precise, definitive resources available on how to deal with many of the items in the top 10. So the first one is the SQL injection prevention cheat sheet. It talks about how to deal with Oracle and SQL Server and Hibernate and things like that. And so I'd encourage you to read that and make that available to your developers so that they know what to do. Cross-site scripting, hopefully we're all familiar with that. Massively evil problem because every time you take user input and echo it in a parameter back into your application, you potentially have the problem. So in the typical application, that means hundreds of opportunities for the flow, thousands of opportunities for the flow. And so even when people try really hard to avoid this problem, they miss stuff. So we need to figure out a way to make this easier, but there are some pretty good defenses now. So I'm not going to go through the attack technique. I'm going to assume you guys are familiar with what cross-site scripting does and how it works. I think one of the things that's really changed for AppSec in the last 4 or 5 years in this space and is reflected in the top 10 is we moved away from focusing on input validation to deal with cross-site scripting, and we moved on to output encoding. Output encoding is so much easier than input validation because you don't have to think really hard about what's legal, and if it is illegal, you don't have to figure out how to react to it in terms of error handling or whatever. Now, we've also done a lot of research on cross-site scripting and found out that it's not as simple as we thought. A lot of people give guidance. HTML encode your output and you'll make yourself safe from cross-site scripting. Well, that's true 95% of the time. Unfortunately, 5% of the time or 10% of the time, it's not true. So read the cheat sheet for cross-site scripting and it tells you, oh, well, there's actually 5 different contexts on an HTML page. And you have to use 5 different encoders depending on the context. You use, of course, only one at a time, but you have to use the right encoder in the right place. So unfortunately, cross-site scripting got a little more complicated in the last 3 years than we thought. So this is a reference discussion of the cheat sheet. It defines the 5 areas that you need to recognize as a developer as your context, and it tells you what encoder to use. And we also give you a method in a SAPI for doing that encoding. So if you're not familiar with the Enterprise Security API project, I would strongly encourage you to do that. That's a OWASP project to provide standard security controls that are easy to use for developers in a bunch of different languages. So we have a PHP version, a .NET version, a Java version, etc. And so I would encourage you to get familiar with that too. And I only have a few more minutes and I have 8 more to go, so I'm not going to go through all these in detail. So authentication and session management, this is pretty much exactly the same kind of information I gave on this topic in 2007. It hasn't really changed. And so we give sort of the standard advice about making sure your authentication is safe, you're using SSL properly, all your change password, recover my password, and things like that are working properly. And we have a cheat sheet specifically on this topic as well. Whoops. Insecure direct object references. This was in the old top 10. It hasn't really changed. It didn't really move very far. But we see a huge amount of failure in this space. When developers have a specific parameter referring to a specific object, whether it's a file or a database record or what have you, it's usually the actual name of the target object. So it's trivial to change that to try to access somebody else's data. And yet people don't quite get that sometimes. So AT&T in the US had a really bad day last week when they lost 100,000 email accounts from their new iPhone 4 wish list, or people signed up for it. And so people just found that they had one parameter on an unauthenticated page where you put in the phone serial number. And so the attacker just iterated through bazillions of them and got 100,000 email addresses out of it, of new clients. So, don't do that. Make sure it's authorized by the user. Do something to make sure that the attacker can't guess the value and brute force access to that object. So just an illustration of this and the defenses against that. So one of the best defenses against this direct object reference that we recommend and we have implemented in a SAPI is to replace the actual reference with a mapping that's specific to that particular user on that session.